So solving quadratic equations, this is just a quick, before I start into the example, explanation of the vocab. So a quadratic equation is different from a quadratic function because a quadratic function has an infinite number of answers. So it's like f of x equals x squared plus 2x plus 1. A quadratic equation would just be something like x squared plus 2x plus 1 equals 5 or 0 or 7 or something like that. So to compare it to what you've done before, a quadratic function, like a linear function, is, so you have f of x equals 2x plus 5. But the equation would be something like 2x plus 5 equals a number, like 7. And then we could solve this one and it would have one answer, but this one has an infinite number of answers because it has that second variable. So really what we're doing for this equation is figuring out when does this function have an output of 7. So we're doing the same thing for quadratics. We have this quadratic function, and now we're looking at a quadratic equation, and this equation would be asking, when is this quadratic function equal to 5? That's the difference between a quadratic equation and a function. It only has one variable, just like this one only had one variable. And these ones we'll learn have either 1, 2, or 0 answers. So that leads us to, well, how do we solve these? Right now we don't know how to solve them, but we can solve them by graphing, and that's what we're learning today. In order to solve them by graphing and actually algebraically as well, we want to have them in standard form. So standard form of a quadratic equation is ax squared plus bx plus c equal to 0. So we always want to have it equal to 0. That's how you solve quadratic equations algebraically. It has to be set equal to 0. For graphing, it's very convenient if it is set equal to 0, but you can solve it if it's not. But it involves finding intersections of lines. So we're going to stick with always having it set equal to 0. So notice that this is the same as the standard form of a quadratic function. The only difference is, again, that you have 0 as your output here, but then here you have another variable as your output. And then your last vocabulary word, and for the standard form, a can equal 0. Remember, if it did, it would not be a quadratic. And b and c have to be integers for it to be in standard form. That's not to say we couldn't solve it if they weren't integers. And then we have roots, which is the solution to any polynomial equation when it is set equal to 0. But right now we're just talking about quadratics. So we're talking about this function right here. The roots would be the answers. What does x equal in order for that to equal 0? Those are called the roots of the equation. And they're actually also called zeros or x-intercepts. So they're called zeros because it's when the function is equal to 0, and they're called x-intercepts because we know when y is equal to 0, that means we're talking about an x-intercept. So here we have your function like this. The x-intercepts would be right here and right here, and that's when y equals 0. So we're looking for the output equal to 0. Well, it would be this one, output equal to 0. So that's why they are the x-intercepts, but we also call them roots and zeros. So if I ask you to find the roots or zeros of an equation, you got to know that I'm asking for the x-intercepts, meaning I'm asking for when is the function equal to 0. So here's how we use those facts. We have this function f of x equals x squared minus x minus 6, and it's graphed right here. As you can see, the x-intercepts are -2 and 3. So what does that mean as far as our equation goes? That means that when I plug in -2 or 3 into my equation, I will get out 0. And if I don't, then they're not the right x-intercepts. So let's just plug it in here to see if it actually works. So we got -2 squared, which is +4, and then minus a negative is +2. Minus 6, 4 plus 2 is 6, and 6 minus 6 is 0. So that works for that one, as we expected. Now we can also do f of 3, and we're going to plug it in to the same equation, and again, we should get out 0. So 3 squared is 9, minus 3 minus 6, 9 minus 3 is 6. And again, 6 minus 6 is 0. So since f of 3 and f of negative 2 equals 0, that means those are the x-intercepts, which are the roots of the equation. So those are our roots. So that means that when we're solving an equation, like the same exact function but as an equation, so x squared minus x minus 6 equal to 0, that's exactly what we're doing in this equation, what we just did up here. We found the x-intercepts here in our graph. That's the answers to this equation, because we're asking when is this function, which is graphed up here, equal to 0. So that's our x-intercepts up there. So we just solved this equation by graphing. Again, there's an algebraic way, but right now we're just doing graphing. So in order to solve an equation like this, you're going to graph the quadratic that's on one side of the equation. And since it's equal to 0, we're looking for x-intercepts. So we're essentially asking, when I ask you to solve this equation, we're asking what are the x-intercepts of this quadratic function.